pained expressions here. What's up?
My site is like not the best. I'm trying
There's
to find
chairs right there.
I know.
All right.
It says we want to what?
Construct
Construct
a 90% confidence interval.
Okay, and then
for the true mean time spent studying.
Okay.
Yeah. It's mostly my writing.
Yeah.
But bad eyesight doesn't help with my writing. Good eyesight doesn't help with my writing. So I really want you to understand. I have to tell you most of the shit you need. Appreciate. I have to tell you X bar. I have to tell you sigma. I got to tell you n. The only thing you have to really look up for this kind of confidence interval is what the z-score is going to be. And it's going to be dependent on what the confidence interval is. And if I don't tell you that, you can't do shit. So I got to tell you this too. And so, did you guys all get that? 1645? So what's this one? Notice in the problem, you don't have to put negative 16. There, that's got the positive and the negative part. So what do I put in for z? 1.645. That's how many steps up and down I want to take. So don't freak yourself out and put a negative in there and then you're like, what's plus or minus and negative? No, it doesn't matter. It's just 1.645. So my best guess is 7.2, and they go up and down from that this many steps. And I've got to change the step size, of course, because I got to sample. I'm talking about sample means. What was it? 1.9 divided by what?
Square root of 82.
Square root of 82. So what I would highly suggest when you do this kind of problem is you calculate this piece first. And then you can just add and subtract it to that, instead of putting the whole damn thing in twice. If you had to give this a name, so if I said, I think it's 7.2, but I could be off by this much, you would agree with a good name might be the error. Right? So we call this part the error. That's how much we think we're off by. It's this, give or take this much. It's how much I think I'm off by. Hopefully some of you guys realize almost everything we've done has led to this. This problem puts everything together that we've talked about just about, except for maybe like nominal kind of variables. I don't know. It's not in there, right? So can you guys tell me what do you get here? If you need to borrow a calculator, by the way, you can do that. We're going to need it in a little bit. Hopefully they have battery. Okay, so anybody help me out there? What do you guys get for that? The error, 7 point something? Sounds too much. Let's see. So yeah, what do you get just for this?
0.345.
Yeah, 0.345. I like that. Now in general, here's the convention for this. You always want to go at least one more place than this is. So you could have went to 0.35, but 0.345 is fine too. You want to go at least one more place. This is one place. You want to go at least two places on your error. I love it. So then what do I get there? If you subtract that and add that to 7.2. So you do 7.2. I love the people, this hasn't happened in a while, but this did actually happen. Somebody came up and said, where's the plus or minus button? Help me God. You do minus 0.345, and then you do plus. It's like on the computer when it says hit any key, and you're like, where's the any key? So what do you guys get? Anybody help me out?
6.855 and 7.545.
All right. Yes, ma'am.
So you want us going up 4 decimal places?
No. So this This is too many decimal places. I mean, it's fine. It's not too many. It's more than you have to do. Like I said, go one more place here than this is. So this could have been 6.86 up to 7.55. That would have been fine. Do you guys see? When in doubt, go a few more places. You're fine. Just don't go 8 places. Jeez, I don't want to look at that. All right, here's the best part of this. We're not done with this problem. You probably know when I say here's the best part of it, you're not going to like it much, but oh well, too bad. This chapter and the next chapter, the very last step is going to be writing a conclusion. Yay! I don't care. Make as disgusted as face as you want to. It'll just make me want to do it more. Now, I'm going to take this away. Everybody got this here? This is all about studying, right? Number of hours studied for students. Okay. So, what the shit does that mean? So we made an interval. Could somebody else, now stay with me, remember, could somebody else do their own study? We took 82 students, right? At least in our little imaginary thing, but we took 82 students, we found an average, an X bar, and we made a confidence interval. Could a different statistics class take their own sample of 82 students? Would they get the same X bar? I would put a lot of money no. So when they make a confidence interval, will it be the same one? Will it be the same as ours? Of course not. If they have a different X bar, their confidence interval is going to be different. Yes? So, there is this mythical beast we're trying to catch. The real average. We don't know what the shit it is. I can't talk to everybody. I can only talk to a group. And then so I get an X bar. So here, I'm going to put X bar 1. Is that cool? For the first group. And then we make a confidence interval. And we're 95%, or in this case, 90% certain we caught the real mean in there, right? That our interval catches. Another group could come along. Another group, Jeff? Yeah, another group could come along. And when they make the interval, they don't catch it. They don't frickin' know. This is real frickin' life. How long? Frickin' I don't know. Right? They don't know. So every time a group constructs an interval, there's a 90% chance that their interval catches it. So what percent of the groups would not actually catch the real mean with their interval? 10%. So when you see a confidence interval somewhere, if it's a 95% confidence interval, there's a 5% chance that the real mean is not in that interval. So here's how we state this. We are farmers, no, we are how confident?
90%.
For this problem, 90% confident that our interval, or that the interval, what's a what? 6.86 what? No, it's not dolphins anymore. Hours. To 7.55 hours. By the way, does everybody agree with me that there is one interval? I know, the older I get, the less I can handle this, but I love it when people put intervals. I'm not going to take points off. I'm going to go, no, there's just one interval. You have to have two numbers have one interval, so stop saying intervals. So that the interval, geez, Jeff, I know, 6.86 hours to 7.55 hours contains the real average number of hours spent studying. What I call the true mean amount of hours spent studying. And when I say true mean, I mean the population mean. So any sample I take is not the true mean, it's an estimate. Confidence intervals makes that estimate easier to interpret. So tell me this, if some other group did this whole thing and they got an interval like 5.2 up to 9.7, which one of us got better results, or maybe did more thorough work or something. Which interval is better? Hours would be better because it's not as wide, right? So again, we could have both gotten the same average. We could have both gotten 7.2. If that's all we report, that's all anybody knows. But if we also report these, people can see, well, they weren't really sure about it, or they were okay and sure about it. It gives more information. So exactly the way they do polls, right? If they say 40% of people are going to vote for Warren, and then at the bottom you notice it says plus or minus 4 points. It could have been actually anywhere from 36 to 44%. Yes? If they say 51% want to impeach Trump, plus or minus 4%, it could actually be less than half of the country or even more than half of the country. So when you hear people saying more than half of the country wants to do that, that's not necessarily true. And again, I'm not going to say which camp I'm in, but maybe some of you guys could figure out. I don't know if this gets annoying. Yes?
Where's the 5.2 and 9.7?
Again, I'm sorry. This was another group. This is just an example. If some other group did this whole thing and they came up with this. So I can't see their work. This is what they reported. I'm not going to necessarily trust this group. Maybe they need to take a bigger sample. Do you guys see if I take a bigger sample, what happens to my error? What happens to how much I'm off by if my sample is bigger? The error gets smaller. Doesn't that match up with what we knew on day one? What's better, a smaller sample or a bigger sample? Bigger sample, because then we're more sure about what we get. This formula is math going, oh yeah, you're right. Because when I take a bigger sample, the error gets smaller. And of course, if I took the entire population, the error goes to 0, because then I know exactly what the shit it is. Okay, maybe. So there's a bit of give and take. How much could I take? How much resources do I have? How many people could I actually talk to? Versus, if I don't take enough, are my results even going to mean shit, right? Okay, maybe not. Yes?
If the number was under 30, would the steps change? If it was a normal?
They would change a little bit. They wouldn't exist because we couldn't do it. Unless it said, so what 2 things could happen that tells me I could do a z-score into a probability? Either the sample size is more than 30, or the problem just says that the distribution is normal, right? If it is normal already, I don't need a sample size to save me. Any sample size works. It's already freaking normal. If it doesn't say it's normal, you need a sample bigger than 30. If we had a statistics 2 class, we could teach what to try to do to get around that. But right now, we can't do shit. All right, so let me give you this. We're coming back to dolphins. Sorry, Stuart. Not the Miami dolphins. Dolphins. Anytime. So just try part A and B. The side that's got section 8.1, the side about dolphins, right? Do the side about dolphins.